To build out our Fibonacci algorithm, we will start by defining it as a function and passing in one parameter called position, which will be a number. Like I mentioned in the previous video, this algorithm is recursive and it takes very little code. Since our function is recursive, let's start by defining our base case. So for our base case, what is the situation in which we immediately know what number is found at the given position in our Fibonacci sequence? Well, there are two situations in which we immediately know what number is at the given position. Since the first two numbers in a Fibonacci sequence are always 1 and 1, we know that if the position equals 1 or the position equals 2, then the number returned to us should be 1. And that is our base case. Let's write it out in code. We will say if position is less than 3, then we simply want to return the number 1. Great. Now we write out our recursive case. So if the position passed in is not 1 or 2, how do we figure out the number at that position? Well, we know that every number in the Fibonacci sequence is the sum of the two numbers before it. So we simply add the two previous numbers together to get the position we are looking for. But a problem for us is that we don't necessarily know what the previous two numbers in the sequence are. If we pass in the position 10, for example, we don't know what numbers are at positions 8 and 9. So how are we supposed to add these two numbers up if we don't know what they are yet? Well, we know that the purpose of our Fibonacci function is to give us the number value of a certain position. So we can just use our Fibonacci function to figure out what those two previous numbers are. This is where recursion comes into play. So in our recursive case, we will say else return Fibonacci of position minus 1 plus Fibonacci of position minus 2. And that is it. That is all it takes to write out our Fibonacci algorithm. Pretty cool, huh? Each of these Fibonacci functions being called in our recursive case will keep calling itself until it reaches the base case, in which both previous numbers are 1 and 1. Then the recursive case will start to unwind and build up the whole Fibonacci sequence until we reach the position that we originally passed in. It is pretty impressive how this little amount of code can build out that whole sequence and be so powerful. Let's test our Fibonacci algorithm in the next video to make sure that it works correctly. See you there.